And a very important point here is that solution can be present in any state, solid, liquid, or gaseous. And another very important point here is that the state of the solvent generally decides the state of the solution. Okay. The state of the solvent generally determines the state of the solution. See here, bacho, we can have solute, we can have solvent. Okay. Solute can also be solid, it can be liquid, it can be gaseous. The solvent can also be solid, liquid, or gaseous. Yes. We have seen the example of a solid solution, that is an alloy. Yes or no? Have we also seen an example of a gaseous solution?
Yes, or air.
Very
Yes,
good.
ma'am.
Air. Wonderful. Yes. So now, beta, in your syllabus, generally we are talking about the solution which has a liquid solvent. Okay. Apart from these two cases discussed, that is alloy and air, we generally have the cases wherein we have a liquid solvent. Okay. So we have a solvent which is liquid. The solute in this solvent can be solid, liquid, or gaseous. Is it clear? In the last class, we discussed the examples of this. Solid solute in a liquid solvent. Can you tell me one example for that?
Can you repeat?
Yes. I repeat.
Salt water, salt water.
Who is this answering?
It's me, Muhammad Ali.
Mohammed, why can't I see you? Okay. You are there in the batch. Welcome back.
I have been here for around 5 minutes.
Yeah, I saw that now. 5 minutes? We didn't even start the class for 5 minutes, Mohammed. Mohammed being Mohammed, huh? No worries. See.
No, I joined 5 minutes ago.
Okay, fine. No worries. See. So a solid solute in a liquid solvent, beta. What is the example? Mohammed, please hold on. I know we have discussed this with you. So solid solute in a liquid solvent. Can we say, beta? Yes, Umaima, please answer.
Sugar solution and salt.
Very good. Sugar and water. That gives you a liquid solution with a solid solute and a liquid solvent. Yes. Also, beta, tincture of iodine is included in this example. Tincture of iodine. What is tincture of iodine? We have iodine.
Alcohol
Yes,
and
very good.
iodine.
Yes. This is a disinfectant solution. Okay, the state of the solution is liquid because of the state of the solvent, which is alcohol, which is in the liquid state, but solute, which is iodine, is present in the solid state. Is it clear?
Yes.
Yes.
Yes, ma'am.
Mohammed, just hold on for a minute, beta. I want to discuss these concepts with them. Okay, just a minute.
Okay.
The very important point is that gaseous solute in a liquid solvent. We have seen the examples of soft drinks,
Yes.
aerated drinks, yes, which have dissolved carbon dioxide in the gaseous form in the liquid solvent, therefore giving you a liquid solution. All these points I think are absolutely clear. Coming on to the next point, okay, that is the concentration. The concentration of a solution. Okay. So I think in the last class we had started this. What do we mean by concentration? What do we mean by concentration? Just the term concentration. Does it give us an idea regarding the quantity of something? Yes, bacho. Does it give us the idea regarding the quantity for something? Yes or no? So the concentration of solution can be stated in 3 terms. Beta see, in 3 ways. Dilution, concentration. So if I say concentrated solution, yes or no? The next is saturated solution or saturation. Okay. See, bacho. Noted it down?
Yes.
The next point here is that dilution, or if I say a solution is diluted or concentrated, those are the comparative terms. Okay, those are the comparative terms. I will call solution A as diluted based on the comparison with solution B, which is concentrated. Okay, so dilution and concentration, they are comparative terms. We will actually learn how to calculate them afterwards. First, beta, our focus is saturated solution. Okay, first our focus is saturated solution. So saturated solution is not a comparative term. Rather, any solution can be saturated. Any solution can be saturated if it has the maximum amount of solute that it can dissolve. If it has the maximum amount of solute that it can dissolve, please keep on writing. These are important points. side by side. I'll not wait afterwards. So saturated solution is a solution that has the maximum amount of solute that it can dissolve. Okay. And please be mindful of the fact that we are talking of the solutions which have liquid solvents, okay? Which have liquid solvents. So we are only talking of those cases. Saturated bacho means full. Saturated means full. So a solution is saturated because it is full. It can no longer dissolve any other solute. Is it clear?
Yeah.
Can I move ahead? All five
Yeah.
of you. Khadija, are you there in the class?
Yes, I'm writing 1 minute.
Yes, Khadija?
Yes, ma'am.
Beta, you join after like 2 to 3 breaks in between and then you join the class. Will this help you in any way?
No, ma'am, I was busy last time, so that's why I couldn't join.
No, that's fine. You were busy, but beta, will this help you in any way?
No, ma'am.
Please try to be consistent, yes?
Yes, ma'am.
Now see, a saturated solution is at a particular temperature, okay? A saturated solution is at a particular temperature. Also, in terms of science, I can also say that so temperature is actually affecting the saturated solution, or the solution is a function of temperature. The saturation of a solution is a function of temperature. Why function of temperature? Because saturation of a solution is changing depending on the change in the temperature. Okay, so saturation in saturated solution. Yes, Mohammed, you wanted to say something.
Yes, I was
What
going
is
to
that?
explain this.
Okay, no worries. I think I explained you.
Yes.
Fine. No. Okay. So saturated solution is at a particular temperature. And why is it so? We'll try to understand it. See, bacho, let's say we have a solution. Okay, we have a solution of salt and water. Okay, salt and water. What will happen is that because salt will dissolve. Acha, can you tell me one thing? All five of you. Will dissolving take place here? And why will it take place here?
Dissolving takes place here, and all the particles of salt get in the places of water because there are spaces between the water particles.
Fine, fine, fine. So does this happen in all the kinds of mixture, or is it specifically in this case?
In like
All mixtures which are homogeneous mixtures. Okay.
Yeah.
And those homogeneous mixtures are referred to as solutions.
solution. Yeah.
Homogeneous mixtures are referred to as solutions. So we have a solution of salt and water. Okay, we have a solution of salt and water. Let's say beta, we say at 30 degrees Celsius temperature, we have two particles of water. Okay, two particles of water. At this temperature, let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 particles of salt are actually getting dissolved at 30 degrees Celsius temperature. If we add more particles of salt, will they get dissolved in these two particles of water?
No.
No. Can I say that at 30 degrees Celsius temperature, these two particles of water are saturated? Yes or no?
Yeah.
Khadija, yes or no?
Yes, ma'am.
Fine. What happens? Let's say, beta, we increase the temperature to 58 degrees Celsius. Okay. 58 degrees Celsius. Just focus on the particles of solvent right now. Ramesh, stop yawning. Just focus on the particles of the solvent right now. The particles of solvent are what? The particles of water, yes. In this case, beta, what will happen? Because the temperature is increased, the kinetic energy of these particles, which are solvent particles, it will increase. They will actually start vibrating faster and they will actually have increased intermolecular spaces between them. Yes or no? Yes or no?
Yes,
So this
ma'am.
comes
Yes, ma'am.
here and this comes here. So now at 58 degrees Celsius temperature, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and so many. Let's say 25 particles of salt are here. At 30 degrees Celsius, only 12 particles are there. Yes. At 58 degrees Celsius, 25 particles are there. At 30 degrees Celsius, the solution is also saturated. At 58 degrees Celsius, the solution is also saturated. But the saturation of a solution is changing depending on the change in temperature. Any problem in this concept?
No.
No.
No, ma'am.
Yes, Abdullah, everything is clear?
Yes, ma'am.
Everything? But why? How does temperature affect this? Why is this changing with temperature?
Because as temperature increases,
Beta,
Ma'am,
Umema, beta, just a minute, okay? Just a minute. I know that.
yeah, because the particles vibrate faster.
Okay, so how does this even help you? If the particles are vibrating faster, how does it lead to
Ma'am,
increased saturation? Yes.
ma'am, the kinetic energy increases
Mm-hmm.
and they
Very
move
good then.
farther apart.
Very good. Khadija, is Abdullah answering in the right way? Is that the right answer?
Yes, ma'am.
And what property of particles is this, Khadija? If kinetic energy is getting increased, what property of particles is this? All four of you will actually keep quiet on this answer, okay? Let Khadija answer. Yes, Khadija, what property of particles is this?
Particles of space between them.
Yes. So particles have a space between them, and if they increase kinetic energy, how does that even affect the particle space? Is kinetic energy related to the space of the particles?
Yes, because the kinetic energy, like if there's more space between them, then like the kinetic energy increases, I guess.
Okay, hold on. All four of you, just tell me one thing. Do you agree with this answer?
Yes, ma'am. What did you say?
Just a second. Yes. My question is, she said that kinetic energy of the particles is related to the space of the particles. Is that true? Yes, bache, all four of you.
No.
No. Umema?
yes,
Yes. Ramesh?
No.
No. Abdullah?
Did you say? I don't know.
Abdullah, you better behave in the class. What is this thing going on? Huh? This is my last warning to you, Abdullah. Yes, Khadija. Any changes in the answer? Mohammed, quickly explain why do you think it's not the correct answer?
Because she was saying that two particles have relation between them. That is wrong. And the correct answer is that when particles are heated up, the kinetic energy is increased. That means the space between them also increases. So there is more space to get into. There are more spaces for salt particles to get into them. So
Ramesh, your answer? Mohammed, I get it.
Yeah, I think something like what he said.
Fine. Bacho, the continuous movement of particles is something that is related to the kinetic energy. I told you one thing in the beginning of the class in the first chapter when we were discussing this, anything that actually leads to the motion of the particles or of movement of anything in the world is actually because of the presence of kinetic energy. So kinetic energy is not related to the intermolecular spaces. That is rather related to the movement of the particles, because the movement of the particles is because of the presence of kinetic energy. I hope this point is clear.
Yes, ma'am.
Yes,
Umaima?
ma'am.
Ramesh?
Yeah.
Fine. Khadija?
Yes, ma'am.
Yes, ma'am. Fine. So at 58 degrees Celsius, the saturation is something different. At 30 degrees Celsius, the saturation is something different. Okay. But at both these temperatures, the same solution is saturated. Therefore, saturation is a function of temperature. What is solubility? What is solubility, beta? The amount of solute at a particular temperature that makes the solution saturated is referred to as solubility. The amount of solute at a particular temperature that makes the solution saturated is referred to as solubility. In the above examples discussed here, at 58 degrees Celsius temperature, 25 particles of salt is the solubility. At 30 degrees Celsius temperature, 12 particles is the solubility. I hope the point is clear. The amount of solute, okay? The amount of solute at a particular temperature that makes a solution saturated. Okay. Therefore, we must have seen this in our day-to-day life that at times we mix sugar in water, it gets saturated, we start heating that solution. We heat the solution so that the solubility of that solution can increase. If the solubility of that solution can increase, we can obviously add more sugar to the solution, okay, and can easily dissolve it. I hope the point is clear.
Yeah.
Let me know. Yeah. I have one more question to all 5 of you. What happens? See, we just now saw that if the temperature increases, the solubility increases. Yes, clearly that is the case. What happens, beta? Let's say we have a solution. Okay, we have a solution which is saturated at 30 degrees Celsius. I decrease the temperature for the same solution and get it at 5 degrees Celsius. Okay, will any change happen? And if yes, what will be that change?
Ma'am, yes, because the particles will like they will slow their vibration will decrease. So the
Okay,
space between them will decrease also. So the
fine,
particles between are less.
fine. Good. Abdullah, one last question to you on this is that the space between the particles of solute will decrease, or of the solvent will decrease, or of the solution will decrease. What happens?
And the solvent
Okay, fine. That is your
space.
answer. Good. Fine. I take that. Any other answer?
No.
Umaima? Yes, Umaima?
I no,
There will be no change in this?
no, they will be changed. Like the particles, the solvent. Like,
Okay, beta, let's say, beta, at 30 degrees Celsius, there were 60 particles, okay? 60 particles, the solubility is 60 particles, okay? At 5 degrees Celsius temperature, what will happen? The solubility will remain same, that is 60 particles. Ramesh, I want the answer from you.
No, it will not remain the same.
Will it decrease or will it increase?
Decrease.
Okay, so can I say, let's say only 10 particles, the solubility is only for 10 particles, yes or no?
Yeah.
So what will happen to those 50 particles?
Yeah, we'll try to find other particles.
Other roots,
Yeah.
other particles, okay.
Oh
Do
wait.
they have a GPS system?
Oh wait, no, they'll just they'll fall to the ground.
Okay, they'll fall to the ground.
Like
Mohammed?
okay.
Yeah, I get your point, Ramesh, good.
Um, Yeah, I had a similar answer to what he said,
Okay.
that when the particles don't have space to get into, they settle down at the bottom.
Very good. All three of you well done. All four of you well done. See what happens here. Extra particles, let's say 50 particles are left here. Yes. They will actually precipitate out. Okay. They will precipitate out. That means they will actually form a precipitate at the bottom of the container that the solution is in. Ramesh, falling down means they will actually precipitate out. Well done. Fine.
Yeah.
Okay. So the precipitation will form out or they will crystallize. They will crystallize. Okay. That means they will just themselves, let's say salt particles were there. So the salt will form a crystal of the salt particles. Okay. That is called as to form the to be crystallized. Okay. So either precipitation will take place or crystallization will take place if the temperature is reduced. Okay. For the same solution. Please note it down. We'll move on to the next point. Have you noted it down, Bacho?
Yes, ma'am.
Oh, no, 1 minute.
Mohammed?
Let me write.
Okay. Yes. Yes. Right. Right. Khadija, are you writing it, beta?
Yes, ma'am.
I'm done.
Abdullah done?
Yes, ma'am.
Mohammed done?
Yes, ma'am.
Fine. Umaima?
Yes.
Fine. Okay. So we have learned about saturated solution and the solubility. A solution which is not saturated is definitely unsaturated. Yes. So a solution which can definitely have more amount of solute at a particular temperature is referred to as a unsaturated solution.
Can you explain it again?
Yes, I can. See, beta. Let's say we had 2 particles of water. Yes. At 30 degrees Celsius, we see that maximum of 12 particles can be adjusted. Yes. We only have 5 particles here of salt. Can I add more salt to this?
Yes, you can.
Yes.
But you don't have.
Yes, ma'am.
Mohammed, stop joking. Okay.
Okay.
This is not a time to do so. Yes, Ramesh. Let's say we just have 5 particles. Can I add more to this?
Yeah.
At the same temperature, I can add more solute to this. Why? Because the solution is still not saturated. It is still not full. The capacity is still not full. Okay. That means this solution is referred to as unsaturated solution. Clear?
Yeah.
Fine. Umaima, done, beta? Umaima, you are not audible to me.
Yes, ma'am.
Mohammed, written?
Yes, ma'am.
Fine.
Done.
Abdullah, Khadija, done?
Yes, ma'am.
Open your NCRTs. Open your NCRTs, bachcho. Please look here. Important points.
1 minute. Let me
Any
grab it.
quickly. Khadija and Abdullah, do you have your NCRTs?
Ma'am, once again, I'll do it.
All of them have gone to grab it. Good. All of them have got their cameras turned off.
Yeah, I got it.
Fine. Yes. Abdullah, Umaima, Khadija, beta, hurry up.
Yes, ma'am.
Yes. Abdullah, Khadija. So, at any particular temperature, A solution that has dissolved as much solute as it is capable of dissolving. That is the maximum capacity. It is said to be a saturated solution. In other words, when no more solute can be dissolved in a solution at a given temperature, it is called as a saturated solution. See, at a given temperature, that means it is a function of temperature. Okay. The next point, the amount of solute present in the saturated solution at this temperature, at the given temperature, is referred to as its solubility. Okay. Solubility. Next point, if the amount of solute contained in a solution is less than the saturation level, it is called as an unsaturated solution. This we have discussed right now. See this one, bacho, we discussed it. Precipitation will happen here or crystallization will happen. Okay. The particles of the solute will crystallize or will precipitate at the bottom of the container if the temperature is decreased. The particles of solute, please note it down, solute particles will be precipitating. Okay. Solute particles will precipitate. Done?
No,
Yes,
ma'am,
ma'am.
one mark.
Yeah,
Okay.
I've marked it.
Fine. Umayma, beta done?
Yes, ma'am.
Khadija?
Yes, ma'am.
See. Next point. We can infer from the above activity that different substances in a given solvent have different solubilities at the same temperature. What does this mean? Let's say, beta, has anyone understood this part? Different substances in a given solvent. That means the solvent is same? Yes. The solvent is same, have different solubilities at the same temperature. The solvent is same, the temperature is same. What is different? The solute is
Solute.
different. Based on the difference in solute, the solubilities will also be different for the same temperature for the same solvent. Is it clear? Let's say
Yes.
30 grams of salt dissolves in 50 ml of water, at 30 degrees Celsius, and this 30 grams of salt makes this solution saturated. On the other hand, if I have lemon juice, okay, let's say only 10 grams of lemon juice makes this 50 ml of water at the same 30 degrees Celsius temperature as saturated. Therefore, because we have two different solutes, we have different solubilities. The concentration of a solution is the amount of this we are going to discuss. Any problem till here?
No, ma'am.
Fine.
No,
Achha, why is
ma'am.
it said? Yes. Okay, fine. Coming on to the next part. So coming on to the part of the concentration, how do I calculate or how do I know if my solution is concentrated or diluted? Okay, that we need to calculate. See, but you pay attention. I need to calculate the amount of solute present in the solution. Okay, in the solution. I can have obviously different amounts of solution. Let's say I have 50 ml of solution and let's say I have 500 ml of solution. Okay. What will happen? If I dissolve the same amount, let's say beta, I dissolve 30 grams of solute in 50 ml of solvent, that is overall solution. Okay. And I dissolve the same amount of 30 grams of solute in 500 ml of solution. Does this make any difference?
Yeah.
Yeah. What difference?
Concentration.
Very good. The concentration is clearly different. So for that, I really need to calculate the concentration. And there are three ways to do this. What are those three methods? First, bacho, is mass by mass concentration. Mohammed, I hope beta you are writing it.
Sorry, I didn't.
It is, I think you should keep a personal assistant who will actually keep on reminding you. Mohammed, please write. No worries, write it. Right. So mass by mass concentration. What happens in this, beta? We have a mass of the solute, okay? We divide it by the mass of the solution, the total mass of the solution, okay? Khadija and Abdullah, beta, writing,
Yes, ma'am.
Yes, ma'am.
okay? And we actually multiply it by 100%. Whenever we want to actually take anything and change that into 100, okay, that we actually use percentage. What does percentage do? It changes everything to 100, okay. Let's say we only have a total of 36 grams, but if we actually multiply it by 100%, that will be the total, okay. So out of that 36%, 36 grams, I will have some percent of the solute and the solvent, okay. Now see, in this there are two methods. The mass of the solute and the mass of the solvent. How do I know the mass of the solution? Mass of solute plus mass of solvent. That will give me the mass of solution. Done, bacho?
Yes, ma'am.
The second is, Umayma, done?
No, I didn't try. I'm doing. I'm
Okay,
writing.
okay. Done?
Yes, ma'am. Done.
Ali, hurry up.
Yes, done.
Done. See, next is volume by volume. What happens? We know the volume of the solute and we divide it by the total volume of the solution. Okay. So volume of the solute divided by volume of solution, okay, multiplied by 100%. Please make sure of the units. In case it is volume, it will be ml or liters, milliliters or liters. If it is mass, it will be grams or kilograms. Okay.
Done, ma'am.
Mom, actually, I
Yes.
have to for the prayer.
5 minutes, Umama. 5 minutes. How much time is there, beta?
Only 10 minutes for Maghrib.
5 minutes. 5 minutes.
Should I come in
5
5
minutes.
minutes?
Come in 3 minutes. Is that possible?
Yes, ma'am.
Go, quickly go. Yes. The third beta, third we have mass by volume concentration.
Ma'am, volume of solution is again volume of solute plus volume of solvent, right?
Yes, exactly. Total volume of solution means we have added the volume of solute and the volume of solvent. Khadija, why can't you beta turn on the camera? Is there
Because
any
I don't,
problem?
no, ma'am, I don't have one on my device.
Okay. Then, so the third one is mass by volume concentration. This means we have the mass of the solute, okay? Mass of the solute and we divide it by the volume of the solution, okay? And then we multiply it by 100%. Percent changes anything to a total of 100, okay? Done?
Yes.
Yes, ma'am.
At your level, we will generally be dealing with the mass by mass concentration. Okay, mass by mass concentration. I'm giving you a question. Please try to solve it, and then we'll discuss on some good questions. Please try to solve this example number 21, 2.1 of 21. Then I'm opening some questions for you.
Ma'am, will write question also? Or no need?
Sorry. No, just try to solve it on our own, just to understand this,
Oh, okay.
and try to be honest. Khadija, are you solving it?
Yes, ma'am.
Ma'am, I got 1/9.
Okay, we'll discuss that answer. Just keep it.
Ma'am, I'm done.
Done, Ramesh?
Yeah.
Done, ma'am.
Fine, fine. Ali done?
Yes.
Muhammad Ali? Fine. 1/9, Abdullah, that's fine, but I think you obviously have to multiply it by 100. Yes.
Yeah, ma'am.
Yeah.
Yes, I forgot.
So no, yeah, that is an important part. Acha, now can you tell me, based on this, all four of you, bacho, what will be the mass of the solvent here?
Mass of solute
Mass of
plus
this
mass of
32,
solvent.
320 grams.
320 grams, that's given. Okay. Mass of solute is given 40 grams. Total mass of the solution, how do we get it?
Mass of solute plus mass of solvent.
Adding.
Wonderful. Fine. Okay. Now just give me a minute. I will have a question for you. Okay. I'm giving you that question. I want all of you to pay attention here. These are important points. Okay. See what happens, bache. If I give you one question, okay, I say 0.01%, please pay attention, 0.01% of NaCl is added to water. Let's assume the solvent is water, okay? I want to know the mass of the solute, the mass of the solvent, and the mass of the solution. This is a question. Okay? The mass of the solute, and this is only this information is given in the question. 0.01% of NaCl is added to water. The mass of the solute, the mass of the solvent, and the mass of the solution. Just hold on, all of you, okay? Just go through it, okay? Done. Now see, important point to be noted here. Let Umaima come, then we'll start with this part.
I'm here.
Umaima, are you back?
Yes, ma'am.
Fine. See, Umaima, gone through this question, okay? 0.01% of NaCl is added to water. The question wants to know what is the mass of the solute, the solvent, and the solution. Fine. See, Victor, what happens at your level, we generally have the mass by mass concentration, okay? Mass by mass concentration. There are three ways in which that question can be asked. First is, just now we saw that mass of the solute is given, mass of the solvent is given. We can calculate the mass of the solution, yes, and then we can calculate the percentage. Yes or no? Just now all of you solved that? Fine. Please respond, बच्चों.
Yes, ma'am, we just solved.
Yes, ma'am.
Khadija and Ramesh. Yes.
Yes, ma'am.
Yeah.
Mass of solute and solvent given, we can calculate it. Okay. The second method to this is that percentage of solute is given. Percentage of solute is given and mass of solution is given. Okay. So in this case, if I ask you the mass by mass concentration, what will you do? I'll give you an example here, bachcho. See, example, I say 35% of solute is there, okay? And the total mass of the solution, beta, total mass of the solution is 150 grams, okay? Tell me the mass by mass concentration for this solution. How will you do this? See, what do we need mass by mass concentration? We need the mass of the solute and we need the mass of the solution, yes or no?
Yeah.
Yes, we already have the mass of the
Yes, ma'am.
solution here. We already have the mass of the solution here. We just need to calculate the mass of the solute. And how do I do this? See, 35%, that means divided by 100 into what? 150 grams. Okay. This will give me the mass of the solute. Yes or no, bachcho?
Yes, ma'am. Thank you.
Yes or no?
Yes, ma'am.
I can't get the response.
Yes, ma'am.
Yes, ma'am.
There's a blank
Yes, ma'am.
response. Only Abdullah is giving me the response. Yes, ma'am. Yes, ma'am. Huh? Umema, Rameez, Khadija, Muhammad.
Yes, ma'am.
Yeah.
Fine.
Yes, ma'am.
So if we
As
calculate it,
responded.
let's say, fine. So yes, let's say somewhere the value comes around to be 80 grams. Let's just assume it, okay? Random value. 80 grams of solute now we have. How do I calculate the mass by mass concentration? 80 total, what's the mass of solution? 150 into 100 grams. Yes or no? 100%.
Yes, ma'am.
Yes.
Understood?
Yes, ma'am.
So this is the
Yes,
second
ma'am.
method. Third method is that, bacho. Third method is that only
Can you
the
show
first
scroll up a little bit? I have to note it down. I was writing half and you scrolling.
second part now.
Yes. Done.
Done, bache? Okay. So the third method to this, third approach to this is that only the percentage of the solute is given. Ramesh, are you there?
Yeah.
Only the percentage of the solute is given. As we just now saw the example of 0.01% of NaCl, yes. Now calculate the mass of the solute, solvent and the solution. See, in this case, beta, what we assume, since no mass of the solution is given, what we assume that total is obviously 100 grams, yes. Because it is in percent, we assume the total mass of the solution is 100 grams, okay. Therefore, this 0.01%, whatever the example, beta, 0.01% of what is given of 100 grams, okay, is given. Therefore, if I calculate it, it will turn out to be 0.01 grams, okay. Yes or no? But you're getting it?
Yeah.
Yes, ma'am.
Okay. Now, if I want to know the mass of the solvent, how will I do that? I'll calculate the percentage of the solvent. How do I do that? 100% minus the percentage of the solute. What is it here? 0.01%. That gives me 99.9%. This gives me 99.9 grams of solvent. Any problem in this? I'll repeat if you want.
No.
Yes, ma'am. Can you repeat?
Yes.
Ma'am, can you explain
See,
again?
yes. See, but in this case, this is the third method. Only the percentage of the solute is given. So how do I calculate the mass of the solute if the mass of the solution is not given? Percentage of what? Let's say, beta, the percentage of solute is given as 0.01%. Okay. 0.01% of what? We don't know. Yes. So we assume it that the total mass of the solution is 100 grams. Okay. Only in cases where no mass of solution is given. Okay. So 0.01% of 100 grams. Yes or no? Respond,
Yeah.
bachcho. So now the 0.01% of 100 grams means what? 0.01 grams?
Yes, 0.1 grams.
0.01 grams. Yes, Ramit and Khadija. Umaima?
Yes.
Yeah.
Yes, ma'am.
Yes. Now through this we get the mass of the solute. In the similar manner, we can get the mass of the solvent. First, we calculate the percentage of the solvent. How do I calculate the percentage of the solvent? But the total percentage is always 100%. Yes. If from this 100%, I subtract the percentage of the solute. Yes, I can get the percentage of the solvent here. Now 99.9% solvent is present, but out of what? Of 100 grams. Yes. So if
Yeah.
I calculate this like this, 99.9%, therefore divided by 100 into 100, total mass is 100, it will give me 99.9 grams because this is in grams. Okay. Got it? Yes or no?
Yeah.
Any problem in this?
No.
No, ma'am.
All 5 of you?
Yeah.
Yes, ma'am.
Yes, ma'am.
Okay. So I'm actually stopping it here. In the next class, inshallah, we'll continue from the next topic. Okay?
Okay.
Okay, ma'am.
Okay, ma'am.
Omema, you can wait for a minute, beta. Rest all leave.
Bye, ma'am.
Bye, ma'am.
Bye, bye, ma'am.
Thank you, ma'am.
Most welcome. Omema, any problem where you left in between? So I hope there's no problem in there. Any problem, you can discuss it.
No, ma'am. I just want to write that third point, like mass by
Okay.
mass concentration.
Oh, you want to write it?
Mass
Just a
by volume concentration.
Is the screen visible, beta?
I have to write that third point of, like, the first one was mass by mass concentration, and the second
Okay,
one.
okay. Oh, just a second. This is it. Okay.
Okay.